Hello, everyone. Welcome back to Grade 10 Applied Math here with Mr. Stone. So we're looking at Lesson 3 now. This is a quick little lesson on the idea of similar triangles. What does it mean when we have triangles that are similar? Now, similar has a sort of regular connotation, but it has a quite a distinct, definite math definition. And it goes that in mathematics, if we use the word similar, it basically is a property that refers to a shape's uniform scaling. Big word. So really, all it's saying is that I'm zooming in or zooming out on a shape. Basically, we have some sort of number, some sort of value, amount, in which we're making all the sides, all of them, bigger or smaller. So say I have this little red rectangle here, and I'm going to make it bigger. And if I make every side length bigger by the same amount, I'm going to get a similar rectangle. These two rectangles are similar because all the side lengths are bigger by the same amount. I'm zooming in at a uniform amount. I'm not zooming in on just a certain part. I'm not changing the sort of the proportions of the thing. I'm not making it skinnier or taller. All the angles are still 90. It's still a rectangle. All the angles are staying the same. Okay? And that's called similar. So in this, we're going to talk about similar triangles. So let's say I have this triangle here, this red triangle. If I just make everything bigger by the same amount, that's a similar triangle. But I can also do a couple other things. I can also just rotate it. Right? I can make this one's a bit smaller and rotate it, but all the sides are still the same. There's still a correspondence, right? We still have this side length and this side length, and then we have the longest side and the longest side. Then we have this one and this one, right? They're still there, and all I've done is done a rotation. I haven't changed any of the scaling. Right? When we're talking about similar triangles, we're talking about scaling. Are things getting bigger or smaller by the same amount, by a constant amount? Right? I can also just flip the whole thing as well. This gets a bit more complicated because we have to just look at what's. Remember, this is the smallest side, longest side, and then we have two others. So we still correspond, but they're still all the same scaling factor. So we've zoomed in on it by the same amount. But if I squish it, let's say, now notice this side here is squeezed, right? These are probably not actually, but everything has changed. The proportions have changed. This one's too short now, right? So this is not a similar triangle. These are all similar triangles, even though we've done some rotations and flips and stuff like that. All the side lengths are all in proportion. This one's gotten a bit too squished, right? We've squeezed it in. It's not a similar triangle anymore. Now, how do we check these things mathematically? Quickly. So really, when we define similar triangles, the way we can do this is we can either say that all the angles are the same. So this angle and this angle have to be the same. Give that little dot to represent that angle. This angle here has to be the same as this angle here. And this angle here, let's put a circle, is this angle here. And the other thing that we're going to use to check is we have to check to see if the corresponding sides are proportional. Now that proportion really just means some sort of fraction. And we're going to see how to do this in the next problem here. And let's say here in these two triangles, let's call them A and B. I'm going to label them with the side lengths. So this one here, this triangle A, has a side length of 4, 6, and 8. And I've labeled them A, B, and C. And then triangle B here has a side length of 6, 9, and 12, and I've labeled it E, D, F. So I've color-coded them according to the corresponding sides. Notice that A, this is the shortest side. This corresponds with the side length D. So why don't we check to see how much bigger, how much we've zoomed in on A to get B. So we're going to take 6, we're going to take the D side here, and we're going to divide it by A. Okay, so we're going to take the D, the this one over here, this black one, and I'm going to divide it by the other black letter over here. So that's going to be d over a, or 6 divided by 4, and it gives us a number of 1.5. So that's telling us for me to go from a to d, all I had to do is multiply by the value 1.5. Okay? Sorry, that's a little messy there. Now let's check the next one. Let's check E and F. F and C. So I took F is 12, C is 8. And if I divide them, I get 1.5 again. Hey, look at that. It's the same number. So when I've gone from C to F, I've multiplied by also 1.5. And for the last one, B and E, sorry, I have 9 and 6. And if I divide them, I get 1.5. They're all the exact same. So for me to go from B to E, again, I multiplied by 1.5. And notice these are all the same. All the numbers are the same. If we get the corresponding sides and we divide them and we all get the same number, those two triangles A and B are similar. And we can write down A and B are similar. Now, mathematicians being lazy, they like to make symbols for things. You put a little squiggle. So A and this translates here. This is math notation for A is similar to B. It's another way you can write that. Right, mathematicians don't like to have to write sentences, so they make up this symbol, and you have to memorize the symbol. But once you know the symbol, you know that means they're similar. Okay, so we've checked and we've shown basically that A and B, these two triangles, are similar. Let's try another example. Let's check these two, A and B. So again, I've color coded them. Notice this. This is the shortest side, so it goes with this one. This is the longest side, so it goes with this one. Let's put a box around it so that corresponds to these ones. This one is a triangle to show that these two correspond, and put a circle to show that these two correspond. All right, so let's do our check. Well, first, before we check, we have to label them, right? So let's label A, B, and C. Well, triangle A, we're going to label them A, B, and C. And then in triangle B, again, we'll go D, E, and F. And notice, again, I've color-coded them to show that which ones are corresponding. So let's check D and A. So we're going to take the bigger one divided by the smaller one. You don't have to, you can have this whole fraction flipped upside down, but then you're going to get, in this case, you get like 0.33334. You're going to get a fraction, or you're going to get a decimal. It kind of makes more sense to see it as the bigger number divided by the smaller number, because it tells us, right, that I've multiplied by 3. The side length there, D, side length D is 3 times as long as A. That's what this is saying. That's what this expression tells us. That D, this length here, from here to here, is 3 times from there to there. Okay, so let's check the next one. C and F. So 3.6 divided by 1.2 gives us 3 again. So again, we see that to go from side length C to side length F, I've multiplied by 3, that same number. Oh, we're almost there. We still have to check that last side. So let's do 3 divided by, 3.3 divided by 1.1. Let's get rid of that for a second here. And that, again, gave us that nice value 3. So notice, look at 3, 3, 3. Remember what it tells us? It means that for us to go from 1.1 to 3.3, again, I multiplied by 3. And they're all the exact same. So we've zoomed in on A by a factor of 3, and we got the triangle B. They're all the same. If, let's say, I did all these calculations and this one turned out to be 2.9, then they're not similar, right? All those 3 numbers have to be the same. Their proportion, the amount that we multiply by each side to get to the new ones, all have to be the same. And if they are, again, we can say that A is similar to B. Remember that this little symbol here, this little squiggle, means similar. Okay? And really, that's it. Okay, this is a nice quick lesson. For your assignment, for lesson 3, they're giving you these 3 triangles. And they look similar. They look all about the same proportions. But we're going to have to check, right? They're going to whole bunch of decimals, so it's hard to tell just by looking at the numbers. So what you're going to have to do is you're going to have to do 3 checks. You're going to have to check to see, is A similar to B? Is A similar to C? And is B similar to C? You have to do these 3 different times. Okay, so basically you have to do 9 of these fractions like this. Right? You have to do 9 fractions, these divisions. All right? So we're going to do it 3 different times. We're going to check A and B, check A and C, and check B and C. Okay? 3 different checks, and you can write down, A is similar to B, or you can even A is not similar to B. Okay, so this is not a too difficult lesson, just a bunch of checking of see if side lengths are similar, or side lengths are proportional, let's say, and to see if triangles are similar. Mathematicians like all these fancy words. All right, okay, so have fun with this, and if you have any questions, feel free to message me, and I'll be talking to you later. Take care, guys.